So welcome to Unit 1 of Pre-Calculus 30. This unit is focusing on trigonometry and the unit circle. Our first goal is to extend understanding of angles to angles in standard position expressed in degrees and radians. And today we will be focusing specifically on developing and applying strategies for converting between angle measures in degrees and radians. First thing we need to find out is, what is a radian? Well, if you look on page 167 of your textbook, you will find the following definition of a radian. 1 radian is the measure of the central angle subtended in a circle by an arc equal in length to the radius of the circle. So, basically, that is not a very good definition for us to understand. So, I'm going to break this definition down, and we will have a better understanding afterwards of what this definition really means. Let's take a look at a circle. So right now, I have a simple circle drawn with the center labeled O. And I have from the center a radius here and a radius here that is extended into a full diameter. But this, we know that each one of these segments is exactly R, 1 radius. So segment OA and segment OB. Now, if we assigned this a random value, we don't know exactly what the size of this circle is, but let's say we assign this a random value of 10. So the radius is 10 units. Doesn't matter what the units are right now. It's just to show a comparison. Now, if the length from point A along this arc to point B is exactly the same as this radius, so this length, this arc length, is exactly R, which in this case is 10. So all of these things are equal. These 2 radii and this arc AB, that means that we will have an angle, which is our central angle, of exactly 1 radian. So this is the size of 1 radian. I did actually pre-measure this angle, so it is accurate. And I've made a couple other radian measures over here on the side. You've probably noticed. So now let's take a look at how 1 radian compares to degrees, or how radians in general compare to degrees. So I can take this pre-prepared radian, slide it into place right onto the center of my circle, line it up. So right now we have 2 radians in this circle. We haven't gone nearly 180 degrees, but you can see that we've gone well over 90, because your 90 line would be about right here. Let's add a 3rd radian in here. So this angle is 3 radians. Now you'll notice that there's a little bit of a sliver left before we fully cover 180 degrees. So 180 degrees, which is why I drew this line as a complete diameter, is just over 3 radians. And in fact, 180 degrees is exactly 3.14. You can carry on with as many decimal places as you want. 3.14 radians. So we can simplify it by saying that 180 degrees is exactly equal to pi radians. That would mean that if we doubled both of them, for a full circle, 360 degrees would be exactly 2 pi radians. Software's having trouble keeping up with me here. Okay, so 180 degrees is exactly pi, exactly 3.14 radians. This will become important for our next step, where we will learn to convert from degrees to radians and back from radians to degrees. So let's start with our first lesson, converting from degrees to radians. Now, I've made a note here, said the first thing I want you to do is make an estimate. And then after you've made your estimate, solve. Now, the reason I want you to make an estimate is that when you get to your final answer, you can compare it with your estimate and see if your answer actually makes sense. If it doesn't, then you might want to go back and consider how you did the problem and maybe take a different approach and see if you can do it and get an answer that actually makes sense. So 180 degrees equals pi radians. Now we have 30 degrees. 30 degrees is significantly less than 180 degrees. Exactly 1/6, as a matter of fact. So if we have an angle of 30 degrees, we would expect that to be, in radians, a lot less than pi. So 30 degrees must be a lot less than 3.14 radians. Now, I mentioned before that 30 degrees is exactly 1/6 of 180 degrees. So our radian measure should be exactly 1/6 of pi. So there are a couple ways to do this. The best way, in my opinion, is to set up a proportion. 30 degrees is to 180 degrees what our unknown value x is to pi radians. So whenever we set up a proportion, when we're converting from degrees to radians, 180 degrees must be in the same respective position as pi. So if we put 180 degrees in the denominator on the left side of our proportion, then we put pi in the denominator on the right side, and vice versa. We could write this proportion as 180 divided by 30 equals pi over x. So if we put 180 in the numerator, then we would also put pi in the numerator. Now the reason I put them in the denominator here is it simplifies our cross multiply a little bit. So I can just take pi and I can multiply it over here by 30 degrees, and I can divide it by 180 degrees, and then we're done our problem. So let's see what this would look like. We take 30 degrees and we multiply it by pi, which again is 3.14. We get 94.2. Now we divide this by 180 and we end up with 0.523 radians. Okay, let's try a second one. Minus 120 degrees. We can set this up in exactly the same way that we set up our last one. We put 180 degrees on the denominator, and that means in our right side of our proportion we put pi in the denominator, and x radians is the value we're looking for. So negative 120 degrees is some fraction of 180, and that is equivalent to x being some fraction of pi. And we carry out the problem in the exact same way, multiply pi over by negative 120 and divide it by 180 degrees. So I don't have a positive negative function on this primitive calculator, so excuse me for not putting the negative symbol in here. We'll just remember that the answer is negative here. We'll multiply this by 3.14 and then we divide it by 180 degrees, and we get 2.093 repeating radians. 2.09. We'll just round it off there. So 2.09 radians. Sorry, this should be a negative. Good job for those of you who caught that. Alright, so let's move on, and now we are going to work backwards. So we are going to convert now from radians to degrees. Now I love when they give me a problem like this and ask me to convert this to degrees, because it has this pi symbol right in it, And this is the easiest way to solve one of these ones. We know that pi is exactly equal to 180 degrees. The best way to do this, wherever you see the pi symbol, simply replace it with 180 degrees. And then you can carry out the simple multiplication and division, and away you go. So 5 times 180, and then divide that by 4, and we get an angle of 225 degrees. Let's try another one. This time we're not given the pi symbol. We are just given a simple value, 2.57 radians. So this one's a little bit trickier. Let's start by working through our known equivalencies. Pi equals 180 degrees. Now if we divided both of these sides by the same thing, that being pi, this ends up being 1. 1 equals 180 degrees over pi radians. We don't have 1, we have 2.57. So if we wanted to turn 1 into 2.57, we would multiply this side by 2.57. And if we do that, then we multiply the other side by the exact same value. 180 times 2.57, and then divide that by pi, 3.14, and we end up with 147.3. We'll round it off there. 147.3 degrees. So what I would like you to do next is pause the video and turn to page 169 in your textbook, and I want you to try the your turn at the bottom of the page. There's 4 quick conversions that you can do, and when you are done you can turn the video back on and I will show you the solutions to those your turn problems, so you can check your answers to see if you've done them correctly. Okay, so pause your video now. Alright, welcome back. So you've done the your turn. I hope everything went pretty well. The first your turn was converting negative 270 degrees into radians, and you should have ended up with a value of negative 4.71 radians. If you didn't, pause the video again, go back, try it again, see if you can come up with this value, negative 4.71 radians. If you did, congratulations, awesome job, give yourself a pat on the back, or go celebrate with some ice cream or something. B was converting from 150 degrees into radians, and I'm hopeful that you came up with this value, 2.62 radians. Again, if you didn't, you can pause the video, go back, try it again, do it the exact same way as you did A, and you should be in business. C, converting 7 pi over 6 radians into degrees. And the final one here, converting negative 1.2 radians into degrees, and hopefully you ended up with negative 68.9 degrees. If you did, great job. So I hope you're understanding this material, and I'll see you in class tomorrow.